Thousand tons of magnesia every year, the bulk of which is produced in Hartlepool, where Steetley pioneered the extraction of magnesia from seawater. These massive tanks turn Steetley limestone into a slurry, which is then calcined to produce both refractory and chemical grades of magnesia. 10 years have seen some major changes in Britain's industrial heartland, and steel making has undergone a revolution. In the year 79 to 80, British Steel made a loss of £1.8 billion. Now it's one of the most successful steel companies in the world, with profits running into hundreds of millions of pounds. Performance like that can only be achieved if everyone involved in the operation does their bit, and that includes suppliers as much as management and employees. This program is about one company which played a part in the British Steel turnaround. They're the people who supplied the bricks this ladle is lined with.
The dolomite is crushed and screened to a specific grading before being passed through a closely controlled burning system.
Is high-purity limestone, which is quarried at Dowlow near Buxton. Here, sophisticated drying, screening and air classification to produce a number of different products. These include burnt dolomite for steel-making flux. These special products plants also have their own rail sidings, so they can exploit the national rail network for maximum speed and cost efficiency while minimizing disturbance.
The Hartlepool Works is one of the largest seawater magnesia operations in the world. First commissioned in 1937, the plant now has a capacity of 250,000 tons a year of magnesia products. The main proportion of this plant's production is for the refractories industry, but chemical grades are also produced and applied in many major industrial processes. The chemistry of producing seawater magnesia is relatively simple. It is the process control, engineering skills and operational expertise Steetley have developed that places them in the forefront of world magnesia technology. The dough lime arrives in these special rail wagons and is slaked to a fine powder in hydrators, formed into a slurry and classified to remove impurities. Seawater is pumped from the North Sea by 4 950 horsepower pumps through pipelines supported on a 650-metre-long jetty. Approximately 300 tons of seawater are required for each ton of magnesia produced, and a total of some 225 million litres of seawater are pumped daily. Before reaction, the seawater is pre-treated to remove calcium bicarbonate alkalinity and minimize lime contamination. This is achieved by a controlled addition of sulfuric acid. The carbon dioxide liberated during the reaction is removed in this desorption tower. Suspended solids must also be removed from the seawater. This is carried out in concrete tanks known as hydrotreaters, where the seawater is filtered through a blanket or suspension of magnesium hydroxide.
Or refractory grades of magnesia. As with the calcined products from Whitwell and Trislington, the
gravity to the center of these large settling tanks, almost 100 meters in diameter, which are capable of settling up to 140,000 tons of magnesium oxide per annum. As the suspension moves outwards across the tank, the solids settle to the bottom as a sludge. This is drawn to the center by a continuously rotating thickener arm fitted with rakes and is removed by means of a pump. The spent seawater overflows a peripheral launder and is returned to the sea. 50% solids is fed directly to rotary kilns. In Route 2, the 50% solids filter cake is fed to a multi-hearth Herreshoff furnace for calcination. The Herreshoff operates at about 900 degrees centigrade, the feed passing down through the 16 levels in the furnace. The resulting powder, a calcined magnesia, is formed into pellets by high-pressure rollers exerting pressure of about 3 tons per square centimetre before being fed to the rotary kilns. This system, operating at pressures up to 140 atmospheres, produces a filter cake of 75% solids content, which is fed directly to the rotary kiln. This produces a pellet-type product without passing through the stages of Herreshoff calcining and pelletization. Six rotary kilns are employed in the final high-temperature sintering to produce a range of refractory magnesia products. The kilns are oil-fired and operate at temperatures up to 2000 degrees centigrade. The plant's largest kiln is 76 meters long with a throughput of 250 tons per day. The Herreshoff operates at about 900 degrees centigrade, the feed passing down through the 16 levels in the furnace.